when I hit record, that is the official start of class. It is 12/20/22. This is week 1 of business math. So I know people get real scared when it comes to the word math and people panic, and this is not time to panic. This is actually not a terrible class to have right now. So I'm going to go ahead and share my screen. I'll try to get through some of the preliminary stuff as quickly as possible. Okay, so everyone should be able to see my Canvas page right there. Hey, Mandy. Good to see. I like when people turn on their cameras. I'm not just talking to names, and that's at least I can see, if you're falling asleep on me.
Yeah, so, that was something they made us do last time. Like Charity was like, "You guys, I need to see you to see that you're actually there."
And what I ask is, if it is possible for you to turn on your cameras, that's fine. I understand. If you're at work or you're, for some reason, turn your camera on isn't an option, I get that as well. I'm not going to force it on you. That's why I use my green screen in the back. Hi, Riley. So I use my green screen in the back because my wife and I share this office. And in the beginning, we were supposed to split it right down the middle, and I have my half and she has her half. What I actually have is a corner now and a maze of boxes and totes and hobby stuff to get through to my corner. So I use my green screen so nobody sees the disaster that the office is, with skeins of yarn and heat presses and Cricut machines and whatever, tumbler turners. So yeah, so that's, so I get it. All right, well, let's go to, everybody should be able to see this screen. Everybody, let's go ahead and go to the business math. Now, what happened is, last time I taught this class, I had, I think, a full 30 students in it. And for a business math class, that is 100% killer on the students and on me. It was pretty rough. So Bob and I have split this up. Now, the advantage is both of us are available to answer questions. You can go to either or on the online classes. So hopefully this is something we're trying, and hopefully it'll work out for everyone. Has anyone here not gotten onto the WebAssign platform? Yeah, we're going to go through it anyway, just for the people who aren't here when they look at it again. I just want to know if anybody hadn't got onto it and had a problem with it. Nobody? Okay. Well, for those people who are not here, who are watching this later, the instructions for the WebAssign sign up is right here. It's a PDF document. It tells you exactly how to get into WebAssign. It is still a Cengage platform, but they use WebAssign for their math classes, so it looks a bit different. And that's why we have a different method of getting into it. Also, excuse me, it's been like that all day. There's also a video to show everyone how to do it as well, to walk you through it.
Even though it's a...
Hi everyone. In this short little video, I wanted to show you how you can create your account with WebAssign.
If you have a problem with it. And also you can email me. And here's the course key when you need it. These are the links to Bob's class at 6, mine at 8. Instructor information for both of us are my 21 tips for online courses. I don't know if everybody's seen that. It's just, I'm not a big fan of these online articles, but this one is actually a pretty good one. It's not going to tell you anything you don't know, but it's going to put it in a format where you have to think, okay, maybe I forgot about this, or it's a small suggestion to help you just tweak what you're doing to go through these classes. I'm not going to spend a whole lot of time on this one today, just because we got way more important things to go through. So I just suggest take the 5 minutes and read it. Mandy was able to get on, awesome. But the one thing I always do play is this 5-minute video by Jordan Peterson. Number one, I love his lectures. Number two, it is name of it here is Why It's So Bloody Hard to Sit Down and Get Work Done. It kind of gives you some insight into why it's really hard to sit down and do your homework. It's a quick video. He's a pretty good lecturer, kind of entertaining. So it shouldn't be that bad. So let's spend 5 minutes watching this, and then we'll get into the next thing. Make sure my sound is on. I'm sharing the sound.
Your attention, for example, is mediated.
Everybody heard that, right? You can hear him. If you didn't notice, he is very Canadian.
Your attention, for example, is mediated by unconscious forces. And you know that perfectly well. And this is another Freudian observation. You know, if you're sitting down to study, for example, your conscious intent is to study. But you know perfectly well that all sorts of distraction fantasies are going to enter the theater of your imagination non-stop and annoyingly. And there isn't really a lot you can do about that except maybe wait it out. You know, so you'll be sitting there reading and your attention will flicker away. You'll think about, I don't know, maybe you want to watch Jane the Virgin on Netflix or something like that. Or maybe it's time to have a peanut butter sandwich, or you should get the dust bunnies out from underneath the bed, or it's time to go outside and have a cigarette, or maybe it's time for a cup of coffee. Or it's like all these subsystems in you that would like something aren't very happy just to sit there while you read this thing that you're actually bored by. And so they pop up and try to take control of your perceptions and your actions nonstop. Maybe you think, well, this is a stupid course anyways. Why do I have to read this damn paper? And what am I doing in university? And what's the point of life? It's like, you can really get going if you're trying to avoid doing your homework. And then you might think, well, what is it in you that's trying to avoid? Because after all, you took the damn course and you told yourself to sit down. Why don't you listen? Well, because you're a mess. That's basically why. You haven't got control over yourself at all. And no more than I have control over this laptop. Okay, so there's the memory function of the unconscious, and there's the dissolutive function. That's an interesting one. The unconscious contains habits, once voluntary, now automatized, and dissociated elements of the personality, which may lead a parasitic existence. That's an interesting one. I would relate that more to procedural memory. You know, so what you've done is practice certain habits, whatever they might be, let's call them bad habits, and you like those things to get under control, but you can't. So maybe when you're speaking, for example, you use like and you know, and you say a lot, and you've practiced that, so you're really good at it, and you'd like to stop it, but you don't get to, because you've built that little machine right into your being, right? It's neurologically wired, and it's not under conscious control, and anything you practice becomes that. It becomes part of you, and that's another element of the unconscious, a different part. And then there's a creative part, which is that, well, you know, you're sitting around and maybe you're trying to write something, or maybe you want to produce a piece of art or a piece of music, or maybe you're just laying in bed dreaming and you have all these weird ideas, and especially in dreams, it's like, where do those things come from? And even more strange, one of the things that's really weird about dreams, and almost impossibly weird, is that you're an observer in the dream. It's like a dream is something that happens to you. Well, you're dreaming it, theoretically, so how is it that you can be an observer? It's almost like you're watching a video game or a movie, but you're producing it, at least in principle, although the psychoanalysts would say, well, no, not exactly. Your ego isn't producing it, your unconscious is producing it. It's a different thing. It's a different thing, and of course Jung would say, well, it's deeper than that. The collective unconscious might be producing it. It's in some sense, It isn't you exactly, or it isn't the you that you think of when you think of you. And that's the ego from the Freudian perspective, the you that you identify with, that's the ego. And outside of that is the unconscious. The id, that's more the place of impulses, and you could think about those as the biological subsystems that can derail your thinking, right? And that govern things like hunger and sex and aggression, and your basic instincts is another way of putting it. And it's a reasonable way of thinking about it, because these are subsystems that you share with animals. You share them certainly with mammals, you share most of them with reptiles, you share a lot of them with amphibians, and even going all the way down to crustaceans, there's commonality, for example, in the dominance hierarchy circuits. And so these are very, very old things. And the idea that you're in control of them is, well, you're not exactly in control of them. And I would say the less integrated you are, the less you're in control of them, and the more they're in control of you. And that can get really out of hand, you know. You can be like with people who have obsessive compulsive disorder, for example, which seems to be, I would say, the dissolutive elements in some sense of the unconscious, the way that it's portrayed here. Poor people with obsessive compulsive disorder, they can spend half their time doing things that they can't really control, and they have very strong impulses to do them, and it's very hard on them to block them, you know. They'll almost panic if those things are blocked. And then you have people with Tourette's syndrome, you know, that they'll be doing all sorts of weird dances and spouting off obscenities and imitating people without being able to control it, and sometimes a little bit of antipsychotic medication can dampen that down, but it's as if there are these autonomous semi-spirits inside of them that grip control over their behavior and make them do things. And you know, you find that to some degree in your own life, because maybe you've become very attracted to someone, even maybe you don't want to be attracted to the person, and then you find yourself, you know, texting them when you know perfectly well that you should be going to bed, and you know, you're in a grip of something, and you can't control it, and that's all part of the unconscious and all part of what Freud was studying.
All right, I always like to play that at the beginning of the classes, just because I think it's really interesting. You know, it doesn't give you any answers of why you have these issues, but it or how to fix them, but it does give you the why. Kind of. Be nice, Autumn. Don't yell at them. So, and I think it just helps, because like he said, why don't you listen to yourself? Well, it's because you're a mess, and just realize you're not alone in being a mess. We're all a mess, constantly. So just realize that these are what we all deal with. Now on this particular class, blah, 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 blah. I'm going to do my obligatory jump up and down and beg and plead and threaten and cajole and bribe. Just do your discussions, guys. I know people hate them. They are 25% of your grade. There are only 3 of them in this class. The first one's not due till next week, so you can get ahead. Remember, they are due on Wednesdays and Sundays. The Wednesday is for your original post. The Sunday is for your peer replies. In a class as large as this, because we're all in the same shell here, I'm not going to, you know, bust anyone's hump for turning in the original post on a Thursday or Friday, because on the smaller classes, what happens is if people are constantly late, then people don't have anything to reply to, and so then everybody's trying to cram it in on the weekend. Here, it's not such a bad thing, but I do encourage you, do your best to get your original one done by Wednesday. Peer replies due by Sunday. It's 25% of your grade, and I will be working on these myself to help you out. And if you actually go to week 4, the one for week 4, you'll see I've already posted to that, and it is very, very much exactly what you need to do yours. And we will discuss it on that week as well. And so I usually don't tell people, so the people who just don't do week 4s don't even look at the other people's posts, where mine is there telling you exactly how to do it. And so, you know, they just kind of lose out. but you, 2, 4, 6, you 6 decided to show up to class today. So let's give you a heads up. And then if anybody took the time to review this video later, maybe they'll know that as well. But please do your discussions. I said we don't have one for week 1, but answer all the questions. It should be at least, oh, Taylor's already done some. Deborah's already done hers. Should be at least 300 words for your original one and 100 words for each for your replies. I know 300 words sounds like a lot, but it's a long email. And I've seen some of you guys text, and you guys can text 300 words before I can even blink. So Riley looks guilty. She smiled. So please, please, please do those. Now, on the assignments. Showing up gets you classroom intensive participation. If you do not show up, you can go in here, do the 300-word summary over the video. The link to the video will be there, and then you will get your points. And just for fun, I love to watch Rocky and Bullwinkle when I was a kid. And so they always had an alternative title. So they had 2 titles at the beginning of them. And so I always put a movie quote as the second title that has nothing to do with the video at all. That one is from Avengers Endgame. I Love You 3000. So when we go to our assignments here, don't forget, if you don't show up, you have the attendance participation. We have 3 discussions here. And then on each one of these, you'll see they give you a due date. Chapter 1 stuff is due the 21st. Chapter 2 is due the 25th. Chapter 3 is due the 25th. I would go ahead and get that done. Nobody wants to sweat getting work done on Christmas night. Okay, there's too many presents, too much food, and too much football to worry about doing this. So let's go ahead and get this done. It just felt like that. They don't give us a break. You know, we move straight through holidays and everything else. So chapter 1, whole numbers. I'm not going to beat up on this at all. It's chapter 2 that I'm going to concentrate on for the next few minutes, and some chapter 3 if I can, because in my limited experience, you know, between college algebra and business calculus and college trig and calc 1 and calc 2, taking all that in college and then teaching high school math for the years that I did. So if you ever, at one point I could have been your freshman, your algebra 1 teacher, or your geometry teacher, or your pre-cal teacher in high school. And in all that time, people always fall short on fractions. Fractions seem to be the big mystery for everyone. And I have learned if you have a really good solid grasp of fractions, a lot of stuff comes really easy. And I think it's usually a mental block, because once you know the rules on fractions, they are not that bad. And let me back up one step. Using a calculator or a spreadsheet is not cheating. Yes, calculators, spreadsheets. When I was going to high school in the 80s, the 1980s, 1880s, whatever you think it might have been, I remember Mr. Osmond, our high school teacher, he told us, you will not always have a calculator wherever you go, so you need to learn to do this stuff by hand. Mr. Osmond, God rest your soul, you lied. I have one in my pocket every day. Cell phone. I can't see it. What? I actually do have a cell phone in my hand. There it is. Yep, see, cell phone. You have a calculator with you at all times. It's not cheating. Technology is a great thing. Please use it. So fractions. Now, you cannot get to the assignments from here. That is one of the things with WebAssign that we have really had difficulty is integrating it in with Canvas. So a lot of stuff, even though we give you the assignments listed here, you have to go into WebAssign to get to them. Now, the good thing here is you'll see chapter 1, chapter 2, chapter 3, all their due dates. You can hit more. This will give you all of them, all the due dates. Okay. Now, I got distracted. I don't know why. Yours isn't going to look exactly like this, but you'll have access to this stuff right here. Now, one of the things I do have access to is where it says messages right here. So you'll know what I see. When I pull this up, I get that. Now, if you'll see here, it says ask your teacher messages. You have an option on in WebAssign to ask me questions. And I don't know who did this, and hopefully I'm not, going to embarrass somebody here. Okay. Jasmine, is she in here? Jasmine, hi, Jasmine. You ask questions. I'll ask permission. Do you mind if I pull this up, Jasmine? Okay. All right. So she pulled it up, and she wrote, I have checked my answer a few times, even left the 8 off. Okay. Bob did there's Bob's reply. She didn't use a calculator. We're just talking about calculators. So, it tells me what she got right, what she got wrong. Oh, and she had a remainder of 58. Now, just remember that your remainder cannot be larger than this number here. If it is, that means that it'll go into this number one more time. Okay. So if you have a remainder of 58 here, like Jasmine put down, then it should clue you off that you have an issue. But I can go to do I not have a calculator on my computer? I guess I don't. Oh, there we go. Does anyone here do anything on Excel? Which I can't see. Hold on. Anybody Excel? Do we have any Excel people here? Okay. We'll just use a calculator. So this question right here was 1317 divided by 25. Okay. Now, what you got here is 52.68. 68, I see what you did here, Jasmine. That's a common mistake. 68 is not the remainder. That is a fraction, okay, or a decimal. What you have here is 25 will go into 1317 52 whole times. So what I'm going to do is I'm going to back up and go 52 times 25. That's 1,300. I'm going to take 1317 minus 1,300, and that is my remainder. You don't use remainders a lot in real life. I understand that. So this is kind of backing you up way into the beginning of math, and you have to rejigger your thinking just a little bit backwards. Oh, no worries. So, and what will happen here is I will go in and reply, and I will be like, what I showed you in class. But there'll actually be a actual explanation there for the most part. Nope, not a question mark. And I'll send that to you, and it'll pop up, and you'll have your answer, and that'll be a help, and it disappears from my screen. So that is a big help. And I'll show you how to get to that. Student view. Let me go to student view here. This is what you guys will see. I've forgotten WebAssign, we have a student view, and the other Cengage platforms, we don't. So I'm going to go to fractions. Now, right here is if you find that you're going to be late, request an extension. I think in the email, I tell you, just tell me why you requested the extension. I use that as I build up that information in class, not to have an excuse to not give you an extension, because I will give it no matter what. I'm just building up data as we go through and see if there's something happening and I need to change the class or the due dates or whatever. So if it's, my kid is sick, just put the kid was sick. Or if I was sick, I was sick. Or if, it was too hard, whatever, that helps me build up some data there so I can make the class a little better down the road. It doesn't help you guys, but it helps students down the road. Okay, you'll have the questions. Here's the Ask Your Teacher button. So if you get stuck, you do that. Bob and I will both see that, so you may get a reply from either of us. And this gives me a chance to talk about fractions. I am going to, as far as fractions are concerned, you have proper fractions, improper fractions, and mixed numbers. A proper fraction looks like this right here. It is one number over another number, and it's a proper fraction. The smallest number is on top. Okay, so the proper fraction, the smallest number is on top. 5/18 is a proper fraction. Okay. And then ask you to write it in word form. And it is 5. Spell here, EIGH 18ths. Okay, so that would be 5/18. And let's see if we like the answer. And it will tell you if you got it right or wrong. We got it right both times. Now, we also talked about improper fractions. Improper fractions are the larger number is on top. Now, let me back up here. A proper fraction is going to be a number smaller than 1. Okay? It's going to be a number smaller than 1. With the number on the top being smaller, what this represents is if you were to take a pie and cut up in 18 pieces, the top number represents how many of those pieces we're talking about. So you cut the pie up at 18 pieces, you take 5 pieces out to feed your friends and family, then you served 5/18 of a pie. Okay, so it's going to be a number less than 1. Your improper fractions, the larger number is on top. Okay, which means you're going to have a number larger than 1. Another way to represent an improper fraction is a mixed number, but we'll get to that in a minute. Now, fractions are multiple different things. One of them is a fraction is actually a division problem. Okay. So let's look at 25/7. And then we're going to back up to the other one for a minute too. But this means 25 divided by 7. So you can put this in 25 divided by 7. So represented as a decimal, 25/7 is 3.571428571428, and it repeats over and over and over again. Now that helps us in a few ways. So we know 7 will go into 23 times evenly. 7 times 3 is 21 with 4 left over. So it goes in there 3 times evenly with 4 left over, and our denominator, which I will get to here in a second, will remain the same. So to convert this into a mixed number, that's exactly what we do. We treat it like a division problem. And boom, we got it right. So, all right. Now, this first one, even though it's less than 1, it is also a division problem. So I can do, well, you read that as 5 divided by 18. When you put it in your calculator, that turns it into a decimal for you. So 5/18 in decimal form is 0.2777777. Okay. We can see it's smaller than 1, right? Now, when you convert a mixed number to an improper fraction, we're going to do the opposite of what we did before. Here's what you do. You take this bottom number, multiply it by your whole number. So 3 times 26 is 78. Add 2 to it. 78 plus 2 is 80. And you put it back over the 3. So it is going to be 80 over 3. And it likes our answer. Okay. I'm going to slow down for a minute because I feel people freaking out on the other side of the screen. Stop me if you need questions, yell at me, wave your hands, hit me on the chat. Anybody have any questions up to this point?
Explain that just like one more time, just so I can understand.
Which one? The last one?
Just the last one.
Okay. If you want to turn this mixed number into an improper fraction, you take the bottom number. Now let's remember what the top and bottom numbers are. In a fraction, the top number is the numerator, the bottom number is the denominator, right? Remember that? So you're going to take your, and then this number here in front is a whole number. Take 3, your denominator times your whole number. So 3 times 26 is 78. And then you add your numerator to it, which is 80. And then you put that whole thing back over your original denominator, which is 3.
Okay, thank you. I appreciate it.
No worries. No worries. So you have just discovered the magical world of fractions. Fractions they're used to represent a part of a whole, and they're also a division problem. They're also a ratio. They're everything. There are a lot of things. But what we care about now is their division problems, and they represent part of a whole. So, and what is this one telling us? Well, let's go back to the pie example. Let's say you had 27 pies. You cut them up into thirds. Somebody ate 1/3 of one of the pies. How many do you have left? 26 2/3 pies left. Okay. Now, on this one, they say use inspection or the greatest common divisor to reduce the fraction to lowest terms. Time check. We got 21 minutes. If you have something that can divide evenly into your numerator and your denominator both, then you can, what you call that is reducing the fraction. So you have to figure out what do they have in common. 4 and 18 can be divided by 2, right? Evenly. In fact, I'm going to stop this. Were you waving at me, Autumn? Okay. Stop this real quick. Okay, everyone should be looking at a whiteboard right now. Okay. So what we had here is 4/18, and they told us to reduce it. 4 and 18, it has, whatever you pick has to go into both evenly. You can't have remainders or any decimals left over. Well, we know you can divide 4 by 2. You can also divide 18 by 2. 4 divided by 2 is 2. 18 divided by 2 is 9. 2 and 9 don't have anything in common, right? So what you've done is you reduce that fraction from 4/18 to 2/9. Now here's what you need to know. You have not changed the value of that number at all. Okay. What you've done is you've just manipulated it so you can work with it in a different way. Now I'm going to show you how I can say that. If you do it correctly, the first one, that represents 4 divided by 18. That is equal to 0.2 off to infinity, right? Now we reduce that to 2/9. 2 divided by 9 is equal to the exact same number. So when you're reducing a fraction, you are not changing the value of it. You're just changing the way it looks. Okay, you're manipulating it so you can work with it in another way, make it easier to work with. So when you reduce a fraction, you are not changing the value. They're worth 2/9 and 4/18 are worth exactly the same amount. And I'm going to show you why that works. Did I hit share screen? Okay. Did everybody get that, or should I go back? No, go back? Okay. Go back to my whiteboard here. Okay, another thing you need to know about a fraction. Anything over itself is always equal to 1. Okay, some basic math stuff. Right? Now, and the reason that's important, we just need to remember that's a thing, but we also need to remember, if you look, what I did here is I actually divided that thing by 2/2. So I actually divided it by 1, a version of 1, right? And so if you divide anything by 1, it's still itself, right? So we didn't change the value. We just changed the way it looked. Now, share. Start share on this one. Okay, so we're back to this screen. Now, you have a few ways of getting help before you even have to reach out to me. You're more than welcome to reach out to me at any time, but you'll see some of these, they have read it. If I click on that, it will take me to the book, into chapter 2. My internet is really slow tonight. Fractions are a mathematical way of expressing part of a whole. The word fraction comes from the Latin word break, blah, 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 blah. and then you can read the chapter on fractions. See here, it gives you same information, numerator and denominator. I didn't talk to you about the division line. I just said it's the same as division, okay? So you can read it. Some of them, let's do this. 2 divided by 9, submit answer. We got it right. We can move on. This one here says, raise the fraction to highest terms as indicated. So they took the 8 and turned it into 64. What do you have to do to 8 to make it into a 64? You multiply it times 8, right? Another clue here is in order to not change the value of your fraction, whatever you do to the bottom, you got to do to the top. Whatever you do to the top, you have to do the exact same thing to the bottom. You can't change anything. So if I multiply 8 times 8 to get 64, I got to take 3 times 8 to get 24. Okay, and it likes the answer. Now, if you have a problem with that, you have read it, but you also have watch it on some of these. And
let's look at this situation. We've got the fraction 2/3, and we want to rewrite it as an equivalent fraction that has a denominator of 21.
So some of them have videos.
Well, to do that, let's decide how many times does 3 go into 21? Well, I'll just divide 21 by...
Okay, so they've taken the time to do that. So you can read it. You can, well, some of you can watch it. You can reach out to me. And if all else fails, go to YouTube. I know it seems weird that YouTube is how I figured out how to rebuild the carb on my motorcycle. I could not figure out what I was doing. So I went to YouTube and somebody rebuilt the carburetor exactly like mine on the exact same motorcycle. And the problem I had was actually getting to it and getting it off to rebuild it. They showed me an easy way to do it when I'd been over there struggling for an hour and a half trying to figure out how to get that daggum thing off. So YouTube is always a good source as well. So at this point, you can read the book. Some of them have videos to watch. You have Bob, you have Stephen, and you have YouTube. There are a whole lot of sources out there. Utilize one or all of them, because that's obviously just telling a 5-year-old to stop whining. You be nice. Don't be mean, hateful. You know, I have a 3.5-year-old grandson, and he is the whiniest, little brattiest baby sometimes. I have no idea. And what I do is I make fun of him. So I was running around I was at my daughter and son-in-law's house last night, and he was being a brat. So I was running around, and I would get in the corner just like he does. And I'd say, leave me alone. Stop it.
I'm not being mean to him. Just
I didn't think you were. I didn't think you were, really.
He's on an extra whiny thing today, and nobody's been in here like helping with him today. There's 3 other adults in this house, and he's like whining and crying, and I'm like, go talk to them, go get a bath, go do that.
I didn't think you were being mean to him. I was just giving you a hard time, Autumn.
I know.
So yeah, kids are a whole nother thing. Okay, so next one on here. Now, just realize that you may or may not have the same numbers we're working with here. Many times they change the numbers. Sometimes you get lucky and get the same numbers. So, hey, kind of, but the problem will be exactly the same with different numbers. Now, this one says a wedding cake was cut into 30 slices. If 24 slices were eaten, what fraction represents the eaten portion of the cake? Reduce your answer to lowest terms. I am going to change my share screen again. Okay, yes, I know, get out of my way. So they said a wedding cake was cut into 30 slices. Uh, 24 were eaten. Now, if you'll notice, I sit down with pieces of paper and I still do a lot of stuff and I write these things out by hand. It doesn't matter if I'm doing a simple fraction like this or if I'm figuring out stresses on a bridge when I was, in engineering, or doing bend radiuses on pipe when I was in horizontal drilling. I always wrote things out by hand. I might put them on a spreadsheet and stuff, but I put them in some sort of order where I kind of understand, keep my mind right. So we have 24 pieces eaten out of 30 total. So there's our fraction, right? Now, conversely, what was left over was 6 out of 30. I know they don't answer that, but this just gives me an opportunity to, you can see, that what was eaten and what was left over should equal to 30, the whole number of pieces. Well, 30 and 24 have something in common. 2 is the easy one, but also an easy one is 6, right? But once again, I'm dividing it by 6 over 6, which means I'm dividing it by 1. I'm not actually changing the value of it. I'm just manipulating the numbers for my own ends. 24 divided by 6 is 4. 30 divided by 6 is 5. They ate 4/5 of the cake. Same thing here. What was left over? So they ate 4/5 with 1/5 left. That makes sense, right? Makes perfect sense. Now, just real quickly, let's say I didn't recognize 6 was my common factor, right? That by 2, but I recognize 2. Be 12 over 15. I go, well, what does 12 and 15 have in common? Can I go any lower? Absolutely. Right? And so just to reiterate, I know I repeat things over and over and over again. I had an old boss used to tell me repetition is the best teacher. And it is. 24 over 30 in value is exactly the same as 12 over 15, which is in value exactly the same as 4 over 5. And if I was to plug 24 divided by 30 in a calculator, 12 divided by 15 in a calculator, and 4 divided by 5 in a calculator, I would get 0.8 every single time for every single one of those. All right. Try to find something that may. All right. Gosh, I wish we had more. I really do. All right, let's talk about some quick rules here. I spent way too much time on some of this. Okay, in order to add and subtract fractions, okay. The one thing you need to know to add and subtract fractions, you must always have the common denominator. Remember the denominator being the bottom number of the fraction. Common denominator meaning the denominator has to be the same. And that's why we just learned how to manipulate these numbers. Okay. You cannot add 1/3 and 1/2 by calling that 2/5. That doesn't work because that's not what it is. In order to do this, you have to make these bottom numbers the same. Okay. And this one's pretty easy. I can turn them both into a 6, right? So I can multiply this 3 times 2. But remember, we also said whatever I do to that bottom number, I have to do the top number. So 2 times 1 is 2. 2 times 3 is 6. Plus, I multiply this times 3, that times 3, which gives me 3, 6. Now I can add those numbers together. That is the only way that will ever work, is you have to add them together. You have to have a common denominator. Okay. Now, when you do that, the denominator remains the same. Then you add the 2 top numbers together. 2 plus 3 is 5. So 1/3 and 1/2, if you add those together, they are equal to 5, 6. Now we could, if we had the proper measuring equipment, like a measuring cup that we could do in 6, right? We could pretty much confirm that. I could have 1 measuring cup here, then I could have 2 measuring cups. I could put half a cup in this one, 1/3 of a cup in this one, pour them all into one, and you would get 5, 6. Subtraction works the same way. So if this was a subtraction problem, which we're going to give negative numbers here, so I don't weird out. I didn't think that far ahead. 2 minus 3 is -1 and 6. Okay, so if you take 1/3 minus 1/2, you have -1/6, which means you've taken more than you actually have, right? It's kind of like writing, for us old timers who used to write checks to the bank. Okay, so adding, subtracting fractions, you have to have common denominators. Multiplying fractions is different. Now, you will still see it every once in a while, but I try to get away from it in this class, is X as a multiplication sign. Okay. Since we're going to be doing a little bit of beginning algebra in this thing, we have to kind of start weaning ourselves off of that. Another way to do a multiplication sign is just a dot. So let's say 1/2 times 1/3. Multiplying fractions is the easiest thing to do. You multiply the top times the top, bottom times the bottom. 1 times 1 is 1. 2 times 3 is 6. You have just multiplied a fraction, done. Okay. You don't have to worry about common denominators when it comes to multiplying or dividing fractions, just on adding and subtracting. Dividing fractions are just a little bit different, though. There's an extra step. I know I've got 1 more minute. I'll finish this step and then we'll cut loose here. And I'm going to reverse these. 1/3 divided by 1/2. Well, it doesn't matter. We don't care. One half divided by 1/3, which weirdly enough, you could also write, you won't see it very often, but just to kind of make a point, you could take 1/2 divided by 1/3, because that's actually a division problem like we talked about before, right? This is the same thing as that. We're not going to do big enough math to have to worry about that second thing. I'm just kind of making a point that, remember, we're talking about division. Now, when you divide them, there's a little thing called it's just KCF, keep, change, flip. So when you're dividing fractions, you keep the first number exactly like it is. You change the division sign to multiplication, and then you flip the next one on its head. So instead of 1/3, it's 3/1. Then it becomes a multiplication problem. 1 times 3 is 3. 2 times 1 is 2. So 1/2 divided by 1/3 is actually 3/2, which is actually, remember, an improper fraction. We can turn this into a mixed number by going 3 divided by 2. 2 will go into 3 one time. 1 times 2 is 2. With 1 left over, 1.5. All right. So it is 9:01. I'm running a little bit late. Do we want to continue for another few minutes, or do you guys think you can muddle through? Autumn says yes. If you,
I do have to go to dinner. They're waiting on me, so I won't be able to.
oh, okay. Well,
I will be sending you a quick email after this about a question though, so I'll let you keep going.
okay. I will, and I'll continue to record so you can look back on this if you need to.
Thank you.
You're welcome. Good night, Riley. So if anybody, it's like I said, it's after time. If anyone absolutely has to leave, you're more than welcome to. We won't spend but another 5 or 10 minutes here. I turned up the heat in the house. Now I'm dying. Oh my God.
Would you do
So
another division?
Sure. Like which one?
Just any division of fractions.
Oh, sure. Okay. Let me put the answer in for this one. What did we decide that was? 4/5, right? 4 divided by 5. It's always nice to make sure we're right. Okay, so give me something to divide, Autumn. Just pull something out of your hat.
Two-thirds and 3/4.
2/3 divided by 3/4. And what we're asking here is, how many times will 3/4 go into 2/3, right? Keep, change, flip. 2/3, you keep it just like it is. You change the division to multiplication. You flip the 3/4 into 4/3. 2 times 4 is 8. 3 times 3 is 9. Done. Just that extra step. And that will be in the book, and there will be videos and stuff on it. Okay. How about you, Mandy? Are you doing all right? And Jasmine and Joanna, I haven't heard anything out of them. Hopefully they're doing well.
Yeah, I think I'm starting to get it.
Okay.
Thank you.
Jasmine's here. She was on the ball. Joanna's good. Oh, Joanna's good too. Okay. All right. Well, hey, no worries. Now, and remember, if you have any questions and you get stuck, number one, if you get stuck, don't suffer forever. Do your due diligence, do your best, and then do this. Ask me a question, help. Try to make your questions, just, I don't get it doesn't help. I mean, that's it. But sometimes, hey, I did this, but it didn't work out. Can you tell me what I did wrong? We don't need to write a whole paragraph. We just need to make it effective communication. Then that, either Bob or I'll answer it. So, and if you get this fraction stuff down, everything else kind of falls into place. And like I said, I learned that when I was in engineering school, and doing calculus, and everything was fractions. You never got anything that was pretty. So, all right. Well, I am going to stop the share here. I appreciate everyone for showing up. If you need anything, I'm 100% here for you. Bob is 100% here for you. Don't freak out if you have a hard time. It's not the end of the world. Like I told one class, because we had another guy in there, when I don't have too many guys in some of these classes, which is I'm used to it as a man. Every lesson I ever learned was the hard way. That's just how we're wired. So, you know, mistakes are just learning opportunities. All right. Well, I am going to stop recording, which is the official